Imagine the entire universe squeezed into a space smaller than a pinhead. That's how it all began, with the Big Bang. This wasn't an explosion like a firework, though. It was more like a sudden, rapid expansion of space itself. About 13.8 billion years ago, all the energy, matter, and even time were packed together incredibly tightly. Then, in a fraction of a second, everything started expanding outward at an unimaginable speed. This expansion continues to this very day. Think of it like blowing up a balloon. As you blow air into it, the balloon gets bigger and bigger, just like the universe did after the Big Bang. The universe wasn't empty space expanding into something else. Rather, space itself was growing. This early universe was incredibly hot and dense, like a giant cosmic soup. But as it expanded, it started to cool down, setting the stage for the formation of everything we see in the universe today. As the universe expanded, it was like a giant cosmic oven slowly cooling down. This cooling process was crucial because it allowed matter to form. At first, the universe was so hot that everything existed as tiny particles smaller than atoms. But as things cooled, these particles began to clump together like tiny droplets of water condensing from steam. Imagine a pot of boiling water. The steam is like the early universe, hot and energetic. As the water cools, the steam condenses into droplets on the lid, just like particles came together in the early universe. This clumping of particles led to the formation of the first atoms, primarily hydrogen and helium, the simplest elements in the universe. These atoms would become the building blocks for everything else: stars, galaxies, planets, and even you and me. Over millions of years, the universe continued to expand and cool, creating the conditions for even more complex structures to form. The stage was set for the first stars to ignite, lighting up the darkness of the early universe. In the vast expanse of the early universe, gravity played a crucial role. It pulled those clouds of hydrogen and helium atoms closer and closer together. As these clouds collapsed under their own gravity, they became denser and hotter. Think of squeezing a sponge in your hand. As you squeeze, the sponge gets smaller and denser. The same thing happened with these gas clouds, and the temperature at their centers soared. Eventually, the temperature and pressure at the core of these collapsing clouds became so intense that nuclear fusion began. This is the process where hydrogen atoms fuse together to form helium, releasing an enormous amount of energy in the process. And so the first stars were born, blazing with incredible brightness and flooding the universe with light for the first time. These early stars were massive, much larger than our sun, and they lived short but brilliant lives. The birth of these first stars marked a turning point in the evolution of the universe, leading to the creation of heavier elements and the formation of the first galaxies. Gravity continued to shape the universe, bringing those early stars together to form vast collections called galaxies. Galaxies are like cosmic cities, home to billions or even trillions of stars, along with gas, dust, and mysterious dark matter. Imagine a sprinkle of glitter on a black sheet of paper. Each speck of glitter is like a galaxy, and the sheet represents the vastness of space. Just like the glitter, galaxies are scattered throughout the universe, forming intricate patterns and structures. Our own galaxy, the Milky Way, is a spiral galaxy, a majestic pinwheel of stars, gas, and dust. It's estimated to contain hundreds of billions of stars, all orbiting around a supermassive black hole at its center. The formation of galaxies is an ongoing process, with galaxies colliding and merging over billions of years. These cosmic interactions shape their evolution and lead to the birth of new generations of stars. Section 5. Our cosmic address, the Milky Way and the Solar System. Our cosmic address is located within one of the Milky Way's spiral arms, about two-thirds of the way out from the center. This is where our solar system, a tiny oasis in the vastness of space, formed about 4.6 billion years ago. Imagine a giant cosmic disk, the Milky Way, with spiral arms swirling outward from its center. Our solar system is located on one of those arms, like a tiny bead on a giant spinning record. The formation of our solar system began with a giant rotating cloud of gas and dust called the solar nebula. Gravity caused this cloud to collapse, and as it did, it spun faster and faster, like a figure skater pulling their arms in. As the center of the nebula collapsed, it became denser and hotter, eventually igniting to form our Sun. The remaining material in the swirling disk around the Sun eventually clumped together to form the planets, moons, asteroids, and comets of our solar system. Section 6. From Dust to Planets, the Birth of Earth and its Neighbors. The formation of planets from the swirling disk around the young Sun was a bit like baking a cosmic cake. The ingredients were simple gas, dust, and ice, but the process, driven by gravity and other forces, was complex and fascinating. Close to the Sun, where it was hotter, rocky materials like iron and silicate minerals clumped together to form the inner terrestrial planets: Mercury, Venus, Earth, and Mars. Farther out beyond the frost line, where temperatures were much colder, ices of water, methane, and ammonia could also condense. These icy materials, along with gas, formed the cores of the giant planets: Jupiter, Saturn, Uranus, and Neptune. Earth, our home planet, formed in the habitable zone, a region around the Sun where temperatures are just right for liquid water to exist on a planet's surface. This unique set of conditions allowed life to emerge and flourish on our planet. Section 7. A universe of wonders, black holes, nebulas, and more. Our universe is not just filled with stars and galaxies, it's also teeming with other fascinating objects, each with its own story to tell. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are formed when massive stars collapse at the end of their lives. Nebulas are giant clouds of gas and dust, often illuminated by the light of nearby stars. They are stellar nurseries where new stars are born from collapsing clouds of gas and dust. Supernovas are explosive events that occur when massive stars run out of fuel and collapse. These explosions are so bright that they can outshine entire galaxies for a short time. Quasars are extremely luminous and distant objects powered by supermassive black holes at the centers of galaxies. They emit enormous amounts of energy, making them some of the brightest objects in the universe. Section 8. The expanding universe, a never-ending journey. Remember that initial expansion from the Big Bang? Well, it's still happening. In fact, the universe is not only expanding, but its expansion is also accelerating. Imagine baking a loaf of raisin bread. As the bread bakes and expands, the raisins get farther apart from each other. That's kind of like what's happening with galaxies in the expanding universe. This accelerating expansion is thought to be driven by a mysterious force called dark energy, which makes up a significant portion of the universe's total energy density. The concept of an expanding universe has profound implications for our understanding of the cosmos, suggesting that it might have no edge and that it will continue to evolve for billions and billions of years to come. Section 9. The future of the cosmos, mysteries yet to unfold. The universe is a vast and mysterious place, full of wonder and awe. While we've come a long way in our understanding of the cosmos, there are still many mysteries yet to be solved. What is dark matter, the invisible substance that makes up a large portion of the universe's mass? What is the ultimate fate of the universe? Will it continue to expand forever, or will it eventually collapse in on itself in a big crunch? These are just a few of the questions that astronomers and cosmologists are grappling with today. As we continue to explore the universe with ever more powerful telescopes and instruments, we can expect to make even more amazing discoveries in the years to come. The universe is a story still being written, and we are privileged to be a part of its unfolding narrative.